Hi everyone, today I'm going to be solving the Leetcode question, maximum value of K coins from piles. This question is the last question of the Leetcode contest that just concluded a few minutes ago. And what it's trying to tell you is that you're trying to solve this problem where there are n different piles and each of them have a positive number of coins in them, and you can only choose one coin from each of the piles, and you have to remove it and add it to your wallet. Um, and and what you want to do is you're given like basically like k different times where you can take money from these piles, and then you want to get the maximum amount. So if you choose k coins optimally, and so there's a couple examples here. You can see 103 and then 789. So if you see here for 100, we can take the first two coins, and then that would get to 101, and then you can see that because all the other ones like 789 is not going to work with the k equals 2. Then here we have a couple piles. Then one that goes all the way from 1 to 700, and then there's 7 different queries. So what you can do is, instead of getting all this money, you can just get all these ones and the 700 from the last pile. So just choose everything from there, and then you get the maximum. So looking at this question, um, there's a couple ways you can solve this problem. One way that I was thinking is you can use a priority queue. Basically, you can store the value in all of these piles, and then put that into a priority queue, which is a max heap in Java, and then keep getting those values and then subtracting that value and then putting it back into the queue. But actually, the way, if you do it that way, it might it's the complexity is going to get higher. So one way to solve this problem, and it's a pretty straightforward way actually, is just using straight recursion, and it's actually very simple to do this recursion, where all you have to do is you can just go through each of the piles and then find the maximum value, and then if you use memoization, where if you use a memo array, you can just solve this problem, and that's actually a very straightforward and simple way to solve it. And initially, when I was solving this problem in the contest, I was thinking I had to use the priority queue, the max heap, but the memoization solution actually works better, and that's the one I went with later on to solve this problem, and it's actually a lot simpler than using that priority queue. Okay, so this is how I solved the problem. As I mentioned, like you can solve it using priority queue is what I was thinking, but it's actually better to do it with memoization. So it's a very straightforward memoization actually. It's pretty similar to like coin change problem. So there's basically two different ways, and it's basically like a recursive solution. So there's two different calls that we make to recursion. First call is we we don't use we go to the next pile. We don't get the values from the current pile, and then we call it recursion. And then otherwise, we have another call where we go through the values in the current pile and then add this to the result. So we have a current result, and then we're checking if we can get a better value. So that's the check get values from current pile. And because we have these two recursive functions, typically if you didn't have memoization, this would be a 2 to the power of n solution, because you'd be going through all the different all the different values, and then this would actually be more than that, because there's two different piles, and it's like a 2D piles that you're checking. So it's actually going to be like 2 to the power of n squared, because of this additional. It's a 2D pile. So if you weren't using memoization, this would be a very inefficient solution. But because we're using memoization, we can reduce a lot of the overlapping sub problems, and a lot of the calls. So we are setting up this memoization, and where whenever the values is already in this DP array, all we're doing is just returning this value again. um, and once and the base case for stopping this recursion is either we have k, which is going to be the number of queries that we have, number of times you can pull values. If it goes to 0, then we return 0. Also, if we get to the end of the piles, and we hadn't used um, all these values we hadn't taken out, then we also return 0. So those are the two base cases. Because right here, if you see in this recursive call where we keep adding I plus 1, so we need to add this equal to size to stop the recursion. And then here we're subtracting from k the current value, and then minus 1 as well because of um, where we are in the pile. So we have that, and then we're getting this result, and finally we set it to the result and then return it as part of this memo. So it's a very simple solution. I was very surprised that this was a solution that works for this problem, because uh, it's basically like the coin change problem, and it was put as a hard problem. So I actually thought it was a pretty easy question. Um, because I had done this coin change problem, which is usually like a medium question. But this is how I solved it, and it's accepted in the solution. And right now, when I submit it as well, you can see that it's working properly and giving the correct solution. So that's it for this video. Let me know if you have any questions about the solution, or have any other problems that you want me to solve, and subscribe for more videos in the future.